everyone, here is the R tutorial of Gaussian Mixture Model. The package we used in R is mclust. It used the EM algorithm to estimate the maximum log likelihood and calculate the parameters in Gaussian mixture models. This package is mainly used for model-based clustering, classification, and density estimation. Because of the time limit in this presentation, I only focused on clustering on this package. I am using R built-in Aries flower dataset. As we know, there are 4 features and 3 classes. Each class has 50 observations. Here, class is the data's labels. X is about data's features. Function mclust is used for model-based clustering. I first run it by default and use summary to view the result. mclust automatically tunes the number of components and the covariance parameterization by Bayes information criterion (BIC). BIC is the log likelihood with the penalty of the number of estimated parameters in the model and observations in the data. The higher the BIC, the better the model. By default, the range of the number of components to be tuned in function is from 1 to 9, and for univariate data, the variance of different components could be either same or different. For multivariate data, there are 14 different covariance parameterization. For the first of clustering, we can see the optimal model is VEV model with 2 components. VEV means for different components, the covariance are equal shape but different volumes and orientation. Here's a plot of VEV model. The log likelihood of this model is negative 215. N means the number of observations. DF means the number of estimated parameters. The BIC value of the optimal model is negative 561. ICL is just another matrix to evaluate the model. Different to BIC, ICL preferred for models with well-separated groups. Again, better ICL means better model. The clustering table shows 2 clusters in the result. The first one has 50 observations and the second one has 100 observations. Here are the table and the plot of 14 different covariance parameterizations. As we are short of time, I'm not going to discuss it in detail. Since we know the Aries data have 3 classes, I redid the mclust by specifying the number of clusters equals to 3. G specifies the number of mixture components to be tuned. Model name indicates the covariance parameterization to be fitted in the clustering. Here I specified 4 different models. In the summary function, if we want to see detailed information about the estimated parameters, we need to explicitly set parameters true. From the result, we see that there are 3 clusters. The mixing probabilities is the mixing proportions of the components. We can see that data came from 3 components with almost the same probability. Means show the mean vector of components, and the variance indicates the covariance matrix of components. Function mclust will return a list, therefore we can use member name to get detailed result. $Z will return the matrix of cluster probability. For example, the 4th entry represents the probability of the 4th observation be classified to the first cluster is 1. $classification will return the clustering labels. $parameters will return the detailed information about the model estimated parameters. We can compare the cluster solution with the true labels to evaluate the model. Table function creates a cross-tabulation. We can see that 50 Setosa are grouped to cluster 1, 45 versicolor are grouped to cluster 2, all Virginica are grouped to cluster 3. The adjusted random index ARI is a measure of agreement between 2 partitions. Higher values represent better partitions accuracy. 0 means the clustering is random partition. Here the result is 0.9, which means the clustering is pretty good. We can also visualize the clustering result. By saying plot model y equal to BIC, we can visualize BIC values. X represents the number of components, Y represents BIC value. Different lines show different covariance parameterizations. By saying plot model y equal to classification, we can generate pairwise scatter plot. The points are colored by the clustering labels. If we only want to show the clustering result of the specific two features, we can use diamonds parameter. Here I specify diamonds equals to 1 and 2 to see the first two features. We can also use the plot model y equals to density to visualize the density function. Note here we cannot use diamonds. For more information about this package, we can refer these materials. That's it. Thank you.